Hi, today I'm going to be looking at properties of parallelograms, rectangles, and squares. Now I know these are common shapes, common figures for most people, but I just wanted to kind of bring these to light, and because we're going to be using some of these properties and their similarities in future examples and future concepts. So first of all, because each of these shapes have four sides, well, first of all, we know they're all polygons. That's what these are called. And because they are multi-sided closed figures, and each of the sides are line segments. And by line, I mean straight line. And so because they're four-sided polygons, they're called quadrilaterals, because quad would mean four. And so then each of these things have their own special characteristics. And so what I'm going to do is I'm going to mark here. So we know, I'm not sure if this actually looks like this, but anyway, so we're going to show that on this parallelogram we see that these two sides, these two opposite sides are parallel, and these two opposite sides are parallel. Okay? And that brings to light one of the properties of parallelograms, that opposite sides are parallel. Okay? And the other thing that we would note also is that if I put these markings here, we also know that opposite sides are equal. So equal in length. Okay, and that's basically all there really is in terms of the sides. I know there are properties in terms of their diagonals, but I'll leave that alone for now. And so that's basically all the properties of parallelograms. And then when we move over to this rectangle, well, we see that again, usually these the side lengths of a parallelogram, or a rectangle, the opposite sides aren't shown with these parallel symbols, but I'll just do that just for consistency with the last diagram that we just drew. So we notice that with a rectangle, and actually maybe I'll just put up here parallelogram, I'll just label each of these. Here's a rectangle. So we notice that opposite sides of a rectangle are parallel. And the other thing that we will note from our knowledge of rectangles is, again, we see that opposite sides are equal in length. So right here that tells us that if the opposite sides are parallel and opposite sides are equal of a rectangle, and these two properties of rectangles are the same as the properties of a parallelogram, that would then tell us that a rectangle is in fact a parallelogram. But it's a special type of parallelogram because the next property of rectangles that we will recognize is that rectangles have four 90-degree vertices. Okay, so the adjacent sides, so sides of the rectangle will, the ones that are side by side, will meet at right angles at 90 degrees. Okay, so the vertices, so the adjacent sides, that's what they call them, the sides that are side by side, the adjacent sides meet at 90 degrees, or they are perpendicular to each other. So that's an extra property of a rectangle that a parallelogram, a general parallelogram, does not have. So therefore that just means that a rectangle is a special type of parallelogram, one that has four 90-degree vertices, which separates a rectangle from a parallelogram. Okay, now we'll move on to a square. And a square I won't show the parallel parts this time, but we notice that, again, opposite sides are parallel. Okay, we know they're parallel. And also, we notice that opposite sides are equal. Equal in length. So we notice from a square that the square is, of course, with the opposite sides parallel and opposite sides equal, which are the same for rectangles and parallelograms. That means that in general, a square is actually a rectangle and is actually a parallelogram as well. Okay, so it's just a special type of each of these. And we also do notice that that adjacent sides meet at right angles. Adjacent sides are parallel or perpendicular to each other. So it has 4 90-degree vertices. So notice that these 3 properties of a square are the same as the 3 properties of a rectangle, which means that a square actually is a rectangle by virtue of these properties being equal to each other. And a square is a special type of rectangle because we have an additional property that says all sides are equal. So not only are opposite sides equal in length, but all 4 sides are actually equal to each other. Therefore, it is a rectangle, but it's a special type of rectangle where all sides are equal. Okay, and I'll just go one small step further. A rectangle has an area formula of length times width. Okay, we can get into this a little bit later on in another video, but if we were to divide the area into strips that are 1 unit in width, then we could build that up to recognize that the area of a rectangle is actually length times width. And the area of a parallelogram, if you may be aware, we say the area of parallelogram is base times height. So if we were to draw this height here, and shame on me for not using a ruler, I'm sorry. There's the height, and so here's the base. If we were to cut this triangle here off this end of the parallelogram and move it over to here, what we actually form is a rectangle. So the rectangle would be formed by this triangle over here in this empty space of the parallelogram. So we form a rectangle, and the base of that rectangle would match up with the length of a rectangle. So the base of the parallelogram would match with the length of the rectangle, and the height of the parallelogram would match with the width of the rectangle. So these two formulas are basically the same thing. We could calculate the area of a rectangle by saying base times height as well to match the formula for the base or the area of a parallelogram, because the rectangle actually is a parallelogram. So we could use the same formula for both. And then if we move over to a square, we know the square, and because we know that the square is a rectangle, we can say that the area of a square is also length times width. But if we know that that each of the side lengths are the same, we could actually say, instead of length times width, we could say it's length times length. But because it's, again, if these are the same length, we don't really even have to refer to it as length. We can just say side length. So side length multiplied by side length. And then there we can go one step further and simplify this and say that the area of a rectangle, or sorry, of a square, is side length squared. So s squared would be the area of the square. Okay, so that shows us all the properties of parallelograms, rectangles, and squares, showing us that the square is a rectangle, which is a parallelogram, And the area formulas indicate to us that the area of a square, being that it is a rectangle, starts with the area of L times W, but then we can simplify it down to S squared. Okay? And we'll get into this. We use this in other videos that I'll produce later on. One of these, I'm going to expand this concept into using this for Pythagorean theorem. And we'll also use this when we get into optimizing the areas and perimeters of rectangles. Alright, so thank you very much for watching, and we'll see you again next time.